Okay, so when we're dealing with logs, in an example such as this, we have to check our answer. All right, and there's some simple ways to do that. And this one here, we just rewrite the whole problem, and then what we want to do is we want to plug in our answer, which was 3 over here. So plug in 3 for x, and we get 3 times 2 minus 4 is equal to log base 2 of 3 plus 2. All right? It's a little blurry there, but this is 3 times 2. Then we have log base 2 of 9 minus 4, which this is equal to log base 2 of 5. Keep simplifying, and really we should be putting question marks here because we're questioning if these are actually equal to each other. So over here we have log base 2 of 5, and that is equal to log base 2 of 5. So now we can check that off. So we have to check these because in a couple examples we're going to be getting two answers right here, and there's potentially only one of those can be correct. So we have to make sure to check each time. All right, let's try part B. Same thing, we're just gonna, well, this is a new lecture, so we'll call it example 1. All right, and solve part A. 4 log base 3 of 2x minus 7 is equal to 8. All right, I encourage you to pause the video and try to work this one out yourself. We're going to start getting into mixing and matching of things, so this problem will not necessarily be worked like this. That's another reason why I'll do another example. So give this a try. All right, so first of all, we need to look at this and say, go through our progression. Can we make the bases the same? No, not really. Then we need to look at it and say, are we in exponential form or logarithmic form, or can I make it into one of those? You know, put it in something that I'm familiar with. And so there's a log in here, so can I make this into logarithmic form? And yeah, I can. I just need to get this log all by itself. This 4 is throwing me off. So divide both sides by 4. Gives you 2. Now we're in logarithmic form, and I don't know how I'm going to get that x, solve for that x, but I do know I can convert to exponential, and let's see if that works. And if it doesn't work, then I'll just go back to this step and try something different. So let's convert to exponential. My base is 3. My exponent is what's by itself, 2, and that's equal to what's left over. And this is going to work because we got this x out from inside of that log, and it's just algebra from this point. So we get 9 is equal to 2x minus 7. Add 7 to both sides, get you 16 is equal to 2x. And divide both sides by 2. So x is equal to 8. And again, you want to check to make sure that this is an answer. So check. And we'll get to examples in a little bit that where it's for me to be able to show you what answer would not be a correct answer. So we'll get to that here in a little bit. This one's going to work out for us, but it's still good practice. So I'm just going to rewrite everything. And now I'm going to plug in 8. And I want a question mark here on the equal sign. 4 log base 3 of 2 times 8 minus 7. And I'm questioning, is that equal to 8? All right, keep going. 4 log base 3 of 16 minus 7 is 9, and I'm questioning, is that equal to 8? All right, So now we have to do a little side work. We can figure out what this log base 3 of 9 is. And some of you may be able to do this in your head, and that's okay. This is log base 3 of 9. So let's set that equal to something. So we're in log form, convert it to exponential. 3 raised to the exponent of y is equal to 9. So that tells me y is equal to 2. So this portion here becomes 2. This 4 stays here. And is that equal to 8? Yes, this one checks out. All right, let's look at another example. Let's just call this part B. Log base 2 of x is equal to 3 minus log base 2 of x minus 2. All right, I encourage you to pause the video and try it. This is going to be, you're going to have to combine several of the past lectures that we've done, and you're going to have to think about it. And I want you to think about these. All right, so give it a chance, and then come back and see me. All right, so we look at this. We can't make the bases the same. We need to look, can I make it into logarithmic or exponential form? And, well, I don't know that I can make it to logarithmic form. I don't know if I can do that, because I have a log over here, and I have a log over here, and I have this 3 minus this log. So I can't do the equivalence property because this 3 is throwing me off. So I need to figure out how to rewrite this or reword it somehow. What do you think about it? What if I added this negative log base 2 of x minus 2 to both sides? And now I have 2 logs on the left side with the same base. Then I can use some properties. Let's just try and see if that works. So let's add log base 2 of x minus 2 to both sides. So log base 2 of x, and now I'm adding this to both sides, plus log base 2 of x minus 2, and that's equal to 3. Now what does this look like over here? I have a log with the same base, and I'm adding these two things together, so that means we can use the product property of logarithms. So I have these two things that are separated, and I'm adding them together and they have the same base, so now I can combine them into one log, and I'm multiplying them together now. Log base 2 of x times x minus 2 is equal to 3. And I'm just using brackets here because too many parentheses can make things confusing. Now you have to ask yourself, what form am I in now? What did I just accomplish? I'm in logarithmic form. So I know now if I'm in log form, I can convert to exponential, and usually out will pop my answer. And vice versa. If you're in exponential, sometimes you convert to log and out will pop your answer. So here I have a base of 2, an exponent of 3, and that's equal to what's left over, x times x minus 2. All right, so let's just simplify this a little bit. This is 8, and now I'm going to multiply this x into both terms. X times x is x squared, and x times negative 2 is negative 2x. Now what do I do? You can pause it and try to think about it for a minute if you want. So what I'm going to do is subtract 8 from both sides. That way I'm going to get all the terms on one side. So if I subtract 8 from both sides, I'm left with 0 over here, which then I'm left with this on the right side. Right? And a lot of people don't like the 0 on the left, I don't really care either way. So all I did was flip which was where, and that's perfectly legal. So now what do I have to do to be able to solve this? You have to do the AC method. So hopefully you're okay, or factoring of however you like factoring. So hopefully you're all okay with factoring by now. So you get x plus 2 times x minus 4, and that's equal to 0. So now you can separate these and say x plus 2 is equal to 0 and x minus 4 is equal to 0. So x will equal negative 2 here, and x will equal positive 4 here. So these are my two answers, except both of them are not my answer, because you have to check. You have to check to make sure that these are valid, that they equal each other. So let's start with the 4. Check. So let's rewrite just the original problem up here. And I'm going to plug in 4 to start with. So log base 2 of 4 is equal to 3 minus log base 2 of 4 minus 2. Alright, keep simplifying. I'm just going to simplify this in the next. I don't want to do too many steps at once. Alright. So hopefully we're getting faster at simplifying this and this. This one should be, hopefully you're getting faster at the shortcuts. This one should be simpler. 2, these 2's cancel out and I'm left with whatever exponent's up here, which is a 1. And then same thing, this here becomes 2. And hopefully you're okay with that by now. 2 is equal to 3 minus 1. If you're not, then just do side work on that. So, and we should be questioning this the whole way down. And so, yep, those are equal to each other. 2 is equal to 2. Yep. So we need to check, so this was check x equals 4. Now we need to check x equal negative 2. And this one is super simple. And this is how you can tell quickly while you're checking. So I'm just going to rewrite the problem and I want to know if these are equal to each other. Now let's plug in negative 2. Log base 2 of negative 2 is equal to 3 minus log base 2 of negative 2 minus negative 2. Alright, and I can keep simplifying here, but we could have told the answer already by now. So this is where we stop at. We haven't dealt with a negative in here. That's because these are undefined. Undefined. We cannot have negative number inside. No negative numbers inside the log function. So when you're doing your checking, if one of them turns out to be negative like that one was, you could stop and say these are not equal to each other because that's undefined. So when you come over here, this is not your answer. Only x equal 4 would be your answer. So you're going to have to know that for the test. This is a good test problem.